Welcome back, everybody. We will be now looking at sampling designs. We'll be looking at sampling methods, simple random samples, stratified samples, and we'll look at some cautions about sampling surveys, and then we'll be looking at some topics where we discuss um, the the relationship between statistical inference and sampling variability. And at the end, we'll be looking at the capture, recapture sampling. Um, so the first sampling method is that we're going to look at is the convenience sampling. Convenience sampling is basically where you just ask whoever is around you. So man on the street surveys are very popular with the TV journalism. They are cheap, convenient, but often quite opinionated and or emotional. Um, and in such sampling, in convenience sampling, since we are just asking whoever is around, the result depends on who's around and on which street or what is the geographical location where you are doing the survey. The So, for example, uh, so results from convenience sampling, um, you know, uh, should not, are not scientific, and they shouldn't be considered seriously. So, for example, so if we are, let's say we are asking, we want to know, we want to know about gun control or legalizing marijuana, right? And by using convenience sampling. So if we do the sampling in Berkeley, then we will probably see that most people favor gun control. But if we do the survey in a small town in Idaho, then we would probably get a completely different result. So, since people in Berkeley tend to favor gun control, and people in a small town in Idaho tend to be more pro gun owners. So even within an area, answer could probably differ if you did the survey so outside of a high school or a country western bird. So if we are still asking surveying about gun control outside of a high school, the result we might see could be completely different from the result we might see in a country western bar. Um, so here the opinions are limited to the individuals who are present. So obviously we will find bias. So convenience sampling should not be used for serious purposes. Um, the next sampling method that we're going to look at is called voluntary response sampling. Um, in voluntary response sampling, individuals choose to be involved. They these are you know they are this They are often called public opinion polls. These are not considered valid or scientific. Um, the bias is basically the sample design here systematically favors a particular outcome. So here's an example. Ann Landers. Ann Landers was the pen name of a Chicago Sun-Times advice columnist, Ruth Crowley, and so she was a columnist at that newspaper, and so she asked her readers to write in about having kids, and was it worth it, and if they had to do it over again, would they do it again? And so she summarized the responses she got from her readers, and what she obtained was that 70% of the parents who wrote in said that having kids was not worth it, and if they had to do it over again, they wouldn't do it. Now, why is this result not valid? Well, the say the most letters to newspapers are written by disgruntled people. So people who have bad experience with parenting, they are the ones who are motivated to write in to this type of newspaper surveys. But if you do a random sample, and if you get a result from a random sample, then it would show that 91% of parents would have kids again. The CNN online surveys, and these are worthless. Again, the bias here is that people. So the example that I'm using here is that the quick vote, right? So they take these quick votes where is the expense of trying to rescue a dog aboard an abandoned ship near Hawaii justified, right? And so you see the results here that 59% said yes and 41% said no. Again, these results are not representative of all the adults in the country. The people have to care enough about an issue to bother replying. This sample is probably a combination of people who hate wasting the taxpayers' money and animal lovers. So these quick votes are not scientific. They don't reflect the opinions of all the adults in the country. So they only reflect opinions of the internet users who have chosen to participate. The results cannot be assumed to represent the opinions of internet users in general, nor the public as a whole. And the quick vote sponsor is not responsible for the content, functionality, and the opinions expressed therein. So you would always see this footnotes in the underneath these surveys. So they acknowledge that these results aren't scientific or valid. Okay, so to get scientific or valid results, we have to look at probability or probability sampling or random sampling. So you have to the individuals must be randomly selected. No one group should be over represented. Random samples rely on the absolute objectivity of random numbers and gets rid of bias. So the random sampling, so recall that we talked about how to pick a random sample by using the random digits table. Um, the So the idea here is that your sampling method is such that in each individual is equally likely to be picked. Simple random sample, what is that? A sample is called a simple random sample if each individual in the population has the same probability of being selected. All possible samples of size n are equally likely to be drawn. So let's say we are picking a sample of BGSU students, and and let's say we are picking 300 students. And so if our sampling method is such that any student is equally likely to be picked, or any sample of 300 students is equally likely to be drawn, then that's a simple random sample. The simplest way to select a random sample is to place names in a hat and then draw out a handful. Okay, so this is the simple random sample. So this is a kind of random sample. Then the next one is the stratified random sample. So here, a stratified random sample is a series of simple random samples selected from subgroups of a given population. The subgroups are chosen to contain all the individuals with a certain characteristic. So for example, divide the population of students into males and females, divide the population of California by major ethnic group, and divide the countries in America, counties in America as either urban or rural based on criteria of population density. The SRS taken within each subgroup need not be of the same size. So we may pick a random sample of 100 male and a random sample of 150 female students. So you don't have to pick the samples from the subgroups are not required to be of the same size. A stratified random sample of a total of 100 Californians representing proportionately the major ethnic groups, right? That would be another example of stratified random sample. So you're picking 100 Californians from each major ethnic groups. Multi-stage samples. Multi-stage samples use multi-stages of stratification. They are often used by the government to obtain information about the U.S. population. For example, sampling both urban and rural areas, and then people in different ethnic and income groups within the urban and rural areas, and then within those strata, individuals of different ethnicities. So multi-stage simply means you are doing multiple stages of stratification. So the individuals are divided into different groups, and then individuals within each group are also divided into groups. So data are obtained by taking a simple random sample from each substrata or from each of the innermost groups. Statistical analysis for these samples is a little bit more complex than for a simple random sample. Okay, a few caution about sampling surveys. A non-response. So some people won't answer because they might feel that they have something to hide or don't like their privacy being invaded. So some people may not have a response. Response bias. Some people may not tell the truth, particularly when the questions are very personal. So, for example, if you're surveying how much do you drink, well, some people may not feel that may not give you the honest answer, and so they might give a false answer. Wording effects. Question wording may affect the response. For example, do you agree that it is awful that so? So this type of questions prompts an individual to give a particular response. So, so the way you word the wording of your question, you can word your question in such a way that you are almost forcing the individuals to answer in a certain way. Undercoverage occurs when parts of the population are left out in the process of choosing the sample. The U.S. Census goes house to house, leaving homeless people, outside the census. Illegal immigrants also avoid being counted. Geographical districts with a lack of coverage tend to be poor. Historically, many clinical trials did not include women in their studies because of their periods and the chance of pregnancy. As a result, many medical treatments were not appropriately tested for women. This problem is slowly being recognized and addressed. So we should always keep in mind that undercoverage may occur if we are not careful. Example, to assess the opinion of students at The Ohio State University about campus safety, a reporter interviews 15 students he meets walking on the campus late at night who are willing to give their opinion. So they are asking people about campus safety, and they are doing it at night, and whoever they meet walking on campus late night. What is the sample here, and what is the population? Well, the population is the collection of the set of all students at Ohio State University, and the sample would be the 15 students they interviewed. And should you trust the results of the first survey, this survey here? Well, the answer is probably not, and because the students who are walking outside late at night, probably they think that the campus is it's safe to walk late night. So they tend to be the students who think that the campus is pretty safe. Here's another example. So a simple random sample of 1,200 adult Americans is selected and asked, in light of the huge national deficit, should the government at this time spend additional money to establish a national system of health insurance? 39% of those responding answered yes. So what can we say about this survey, and should we trust the results of this survey? Well, even though it looks like, okay, we are picking a sample randomly, which is great, however, the wording of the question here could be questionable. That is, you are in your question, you are all you are kind of when you say that, when you start with huge national deficit word in the question, the responses will tend to be in favor of not having a national health care system. The sampling process here is sound again, but the wording is kind of biased. The results probably understate the percentage of people who do favor a system of national health insurance. Okay, so again, we looked at a couple of sampling method, and the sampling method that one should use would be random sampling. And for within random sampling, we can just look at simple random samples, or we can look at the stratified random samples, where we pick simple random samples from subgroups of the population. And then multi-stage samples is where we have groups within groups, and we pick simple random samples from groups within groups. Okay, so let's so we're done with talking about sampling design. Now let me end by saying a little bit about what we will see later. So statistical inference, obviously we pick samples because we can't possibly do measurements for the entire population of individuals. So we draw inferences or conclusions about a population from estimates based on samples. The estimate of the population is only as good as the sampling design, so we must pay attention in the designing process to eliminate biases. The estimate obviously vary from sample to sample. So let's say in the 2020 presidential election, we want to know the percentage of voters who favor President Trump. And so if we pick a simple random sample of voters, the result that we see may not be the same if we pick another simple random sample of voters. So the estimate vary from sample to sample. However, the bigger the sample, the better the estimate. Is. So as I said, from the estimate, so the estimate will vary from sample to sample. So there is this sampling variation, and the sampling variability is simply talking about the variation we see from sample to sample. We are highly likely to obtain a different set of individuals and calculate a different statistic each time we select a random sample from a population, and this is known as sampling variability. However, if we take lots of random samples of the same size from a given population, the variation from sample to sample, the sampling distribution will follow a predictable pattern, and all statistical inference is based on this knowledge. So basically what I'm trying to get at is, let's say we are looking at again the 2020 election and asking people whether they favor Trump, and we were looking at the proportion of voters who favor Trump. So each time we pick a sample of size, a sample of 100 voters, and we look at the proportion of voters in the sample who favor Trump. And so let's say these are the proportions that we are getting. Again, I'm just making this up here. And then even though we see this variation from sample to sample, the distribution of these proportions or this sample statistic here, by sample statistic I mean the proportion that we're looking at here. The sampling distribution of this sample statistic kind of follow a pattern. So and then we can use that pattern to make inferences. Again, we'll be looking at this idea in greater detail later. The sampling variability of a statistic depends on the sampling design and the sample size. Larger sample sizes lead to lower variation. Quick vote online surveys are worthless. No matter statistics from large samples are almost always close estimates of the true population parameter. However, this only applies to random samples. Quick vote online surveys are worthless no matter how many people participate, because they use a voluntary sampling design and not random sampling. Okay, the last slide, capture, recapture sampling. So repeated sampling can be used to estimate the size of a population. So let's say we want to know the size of a bird. So let's say we want to know what is the number of a bird species. So what we can do is we can catch some of the birds and we can tag them and release them. And the following year we can catch some birds again, and then we can look at how many birds are tagged and how many birds are not tagged in the second year, and then the proportion of tagged birds in the sample should be a reasonable estimate of the proportion of tagged birds in the population. So let's say that in year one we sampled 200. We caught a sample of 200 birds, and we tagged them and we let them go. And in year two we catch let's say 132 birds, and we found that 12 of them were tagged and 120 of them were not tagged. So let's say capital N is the true populations, capital N is the total number of birds in a specific geographical area where we did this study. And so the proportion of tagged birds we see in the second year in the sample should be about the same, or should be about the same as the proportion of tagged birds in the entire population. So then we see that the 12 out of sorry, I think I said something wrong. So we in year two we caught 120 birds and 12 of them were tagged. So the proportion of tagged birds in the sample in year two would be 12 over 120, and that's about that should be about the same as the proportion of tagged birds in the entire population. So there is a total of 200 tagged birds over the total number of birds n. So from this equation we can calculate what n is. So n here it turns out to be 2000. So capture recapture sampling can be used to estimate the size of a population. Okay, so this is it, and that will be the last video on this chapter, and I will hopefully see you in the next video.